Hello students. In the chapter on vector analysis, so far what we have studied is how to differentiate scalar and vector functions. In this chapter, we will study how to integrate vector function. At first, let us see what is the meaning of integration. Integration means addition of continuous quantities. Take the example of the work done to raise the body from the surface of the earth to the certain height against gravitational force. Normally we calculate the work done by multiplying force into displacement. But in this case, the force does not remain constant for the displacement from surface of the earth to a certain point. It decreases with the height. So it is not possible to calculate the work done by using the formula force into displacement because the force is not constant over a given displacement. In order to calculate this work done, what is done is the force work done to move the body to very small displacement tending to 0 is calculated. Here the force remains almost constant over such a small displacement. Hence, the work done to move the body through this displacement can be calculated using force into the displacement. Then, to get the total work done to move the body from the surface of the earth to the certain height, one can calculate by integrating this work done from the lower limit, which is the surface, to the upper limit, which is the point where it is raised. So this is how the integration is done. There are three types of integral. First one is line integral, where integration is done with respect to length, that is a distance. Second type of the integral is a surface integral, where integration is done with respect to the surface area. Third type of integral is volume integral, where integration is done with respect to the volume. Now let us first define line integral. Let us consider there is a path from A to B. It is shown as a curve C in this diagram. Let us say that at some point P, some force vector F is acting. Then let us take a very small part of the position vector, infinitesimal part of that position vector, vector dr. So dr is very small, tending to 0. It will make some angle. This force F and that dr will make some angle, let us say theta. Then for this small displacement, the work done will be F dot dr. And to find out the total work done, add this small work done from A to B And that can be done with the help of integral with lower limit a, upper limit b. So this is what is called as a definite integral when you integrate from a to b. Now this f dot dr is f dr cos theta. So f cos theta is a component of vector f in direction of vector dr. So in technical language, line integral of function vector f along C from a to b is defined as definite integral of component of f in the direction of tangent to the curve at P. So component is that component dot f in the direction of dr. Tangent means tangent to that curve, that is the direction of dr. So this line integral equal to integral a to b vector f dot vector dr. If vector f is a force and if we are able to express it as minus grade of phi, then that phi is called as a potential, and in that case a given force is conservative. The meaning of the conservative force means that the work done due to this force is stored as a potential energy. Now we will find another condition for the force to be conservative. The force is conservative if curl of that force is equal to 0. That is, vector del cross vector f equal to 0. Then one can say that vector f is a conservative force. Now let us prove this. Now let us say that force vector f is conservative. Now if the force vector f is conservative, then as we have given on the top, that vector f can be written as minus grade of phi. That is equation 1. Then on both the sides, that means on the left hand side of this equation 1 and the right hand side of the equation 1, you take the curl. Curl means del cross. So on the left hand side, when you take a curl, it becomes del cross f, and on the right hand side, when you take a curl, it becomes del cross minus grade phi. But we have proved in the differential identities that curl of gradient is always 0. So on the right hand side, this minus sign comes out, and what remains there is del cross del phi, that is curl of the gradient of the scalar function. So that is equal to 0. So therefore we get del cross f equal to 0. That means to test whether the given force is conservative, find the curl of that force, and if it is 0, then that force f is conservative. Now let us see how to find out whether given force is conservative or not. Let us take this problem where vector f is given to be equal to xy square I cap plus x cube y j cap, and we have to show that it is not conservative. Now here xy square is the x component, x cube y is a y component. There is no k cap there. That means the z component is 0. Now to show that this vector f is not conservative, we have to show that curl of that vector f is not equal to 0. So let us calculate now what is that curl of the vector f. Curl of the vector f means del cross f. We evaluate this del cross f by using 3 by 3 determinant, where The first row contains unit vector I cap, j cap, k cap. The second row contains the components of the first vector, that is del, whose components are dou by dou x, dou by dou y, and dou by dou z, and the third row contains the components of vector f, which are x y square, x cube y, and 0. Then evaluate this 3 by 3 determinant by converting into 2 by 2 determinant, and evaluate that 2 by 2 determinant by finding the product of diagonals and subtracting them. Now in this case, it results into 3x square y minus 2xy k cap. So this is not equal to 0. Therefore, given force vector f is not conservative. Surfaces are of two types, closed surface and open surface. In a closed surface are the surfaces which enclose the volume. Example, a sphere. Surface of that sphere is a closed surface because inside there is a volume. A cube, its surface is a closed surface because inside there is a vacuum. In the open surface, this surface does not enclose any volume. Example, a single sheet of the paper is an open surface. Now this closed surface or open surface have the area, there is a surface area. Normally, area is a scalar quantity. It does not have the direction. But sometime, because of the mathematical purpose, especially in some formula to express certain quantities, the area is to be represented as a vector. That means, beside the magnitude of that area, a direction is to be specified, and the direction of an area vector is given as direction which is perpendicular out of the surface. So any area has a magnitude. Examples, a square, length square, rectangle, length into breadth, sphere, 4 pi r square. Beside that, this area will have the direction. So direction at a given point is perpendicular from that point, pointing outside that surface. So that gives the direction of area vector. The line integral, as I mentioned earlier, it is integration with respect to length. So it is represented like this. This is a symbol. In fact, here, if the limits are not given, that means it is indefinite integral. So integral of d lambda, or we write integral d lambda, and here lambda, when we write below this integral sign lambda, it shows it is a line integral. Now a quantity which is inside the integral, in this case d lambda, it is called as the integrand. So this is a symbol for the integral, and quantity which is integrated, that is called as integrand. Then surface integral is integration with respect to the surface area. Now surface area is two-dimensional. So length into length, or length into breadth, or pi r square. R square, that means it is two-dimensional. Since it is two-dimensional, so two lengths are involved. So that's why it is to be integrated twice. It is called as a surface integral, is called as a double integral. And here that d sigma, sigma means the area. Now instead of writing two integrals like this, you can write a single integral and show below that sigma, sigma or s to show that it is a double integral. That is a surface integral. Next, volume integral is the integral where integration is done with respect to the volume. Now volume is a three-dimensional quantity. So there are three lengths. So the volume is to be integrated thrice. So volume integral, we write it with a symbol or signs of three integrals, and inside what is there is dv. Now instead of writing signs for the three integral, you can write a single integral, and below that you can write v or tau to show that it is a volume integral. Here we will study the meaning of normal surface integral. It is a surface integral, that means the integration is done with respect to the surface area, and it is called as a normal surface integral, and the word normal is used because direction of the area vector is always the normal, that is a perpendicular to a point on the surface. The definition of this normal surface integral is similar to that of the line integral, only here since it is a surface integral, it is a double integral is there, and the increment here is vector d sigma. Then this vector d sigma is written as its unit vector into d sigma, and unit vector is written as n cap. The symbol n is used because a direction of this unit vector of the area vector is perpendicular, that is normal to the surface area.